This is Gary Marv, Glendale Community College. This screen capture is for my SAS 150 AB students. And in the screen capture, I'm going to talk about Assignment 8. Assignment 8 deals with creating a class file in a driver class application to consume that class file in pseudocode. So the instructions for the assignment are up here on the screen now. Let me send this a little better. There we go. And essentially, it's going to ask you to create a class called Coffee, I would assume, or whatever you want to call it. It's going to have the following instance variables or properties: names, product ID, cost, prep time, sizes, etc. It's going to have get and set or access or mutator methods. It's also going to contain a public method for printing a coffee label that can be stuck to the side of the coffee cup. This is much like what Starbucks does. If you go to Starbucks and you place an order, it's busy. What they'll typically do is take your order, you'll wait for your coffee, but typically also you'll get a paper label on the coffee that has your name and also what your order is. That's what we're trying to simulate here. Now, in the background, I've got my pseudocode up and running here in Notepad. And this is going to look a little bit like Python, but not exactly. And if you're a Python purist, then don't expect it to be exactly like Python, because I need to take some poetic license here in explaining how classes work. In Python, like a lot of languages, a class file is first identified by a keyword called class. Typically, by convention, when you have a class file name, it's got to be letters and numbers, all contiguous, consecutive, no spaces. The first letter should be an uppercase letter. That's a standard that exists with most classes. There will be parentheses to take parameters. These parameters, though, will be used for identifying, at least in Python and a lot of languages, a parent if one exists. Now, I have another video that I'm going to do that involves inheritance. It's also more Python-y than this one, so this one's kind of a mixture of Python and pseudocode, but the other one has actually inheritance happening, and I can show you that one in another video. My state or instance variables are deposits, checks, and balance. And keep in mind, the noun in this activity is checkbook. That's the thing this class represents. The adjectives and adverbs are down below. Deposits, checks, balance. In some languages are called properties. Sometimes it's called fields. Sometimes it's called data. It's essentially what we would call an instance variables, or variables in data that will be held with an instantiated checkbook object. More about that in a minute. It's got a method called current balance, which is similar to our printf for our coffee label, which simply has some, standard expressions. They could be loops, they could be if statements. These are simply print statements. This is a very simplified method. And remember, methods are no more than functions that are owned by classes. Modules, functions, methods are all essentially the same thing, but depending on where they're used, they could have a different name. A module is commonly used with pseudocode. A function is normally used with languages like C and Python. A method is any class that owns a function. So this would be a method. It also has a method pair for every one of the instance variables. If the instance variable is a read and write. If the instance variable is a read only, then it's only going to have a get, but we'd expect every one of these to have a get and a set. So deposits has a get and a set and a get. Checks has a set and a get, and the balance does not have one because balance would be only a read-only property, and it's only used inside this method. It's never actually made accessible to any code outside of this class. And that's common. I mean, basically, when you design a class, you're going to put, as a programmer, as many protections as you can to prevent other programs from breaking your code, programmers from breaking your code. And since the balance is basically a calculation between deposits and checks, I want to have full control over that. So I do have a variable in here to capture it, but it's only going to be calculated if someone calls the curl-val method. Okay. Now, there's the end of my class. Python code blocks and class are identified by indentation. That's kind of consistent here. Let's see, what else can I say? Again, Python doesn't use the word function. It uses the words def instead of function. Def is short for define. Down here on line 33, I'll barely out of view. Let's move this a little bit. 33 is technically the start of the program. This class file is read, it's put into memory, but it's not used until called. Well, lo and behold, on line 35, the comment is line 34, I want to instantiate a copy of this object in memory. So what that does, it looks at checkbook and takes all of its instance variables and all of its methods there and stick those in memory. and associate those in dot notation with Gary, and then also it does it again with Mike. Down here, what I'm going to do is take that instantiated value of Gary, and I'm going to call specifically the set deposits method, which is the set method, which updates my instance variable to make it 100. So up here is a set right there. It's going to pass it 100. It's going to say, is 100 positive? Oh, yeah, it is. Okay, I'll set it then. If this value wasn't a positive number, it would give me a message and end the program. This, again, is my part as the designer and developer of this class to make sure people don't put bad data in my class. Now, this is a rather harsh exit from the program. In real life, I probably not want a hard exit. I'd probably want to give someone an error message and the ability to fix it. But right here, it's a hard exit. The next thing it's going to do is Gary is one instantiated part of memory. Well, in memory, there's also a class object that's been instantiated called Mike. So there's two different class objects of Checkbook. One is called Gary, and one's called Mike. They're two different blocks of memory, so they're going to have two different values. Just so happens they both have 100. I could make this 110, maybe just to illustrate there's a difference. The next statement, simply a print. After that, I'm going to set the deposits to be, again, there's my set deposits called 100 plus get deposits. Now, set changes the instance variable, get retrieves it. So this would have a value of 100, and up here I would have a get. And get simply just returns whatever the deposits instant variable is currently at. So if it's at 100, 100 plus 100 would now make the Gary value to be 200. Now in the Mike value, it's different. In the Mike value, I say, okay, take whatever's in there, which is I guess now 110, and add 1009 to it. So that's going to have a much larger number, but again, it's a separate account and ends in a separate block of memory. Next, I'm going to set the checks for Gary and the checks for Mike, same as with deposits. It's going to come up here, look for a set. There is one. I'm not checking to make sure it's a positive number because this is kind of a simple example. You're going to find another example which is much more robust and checks for a lot more stuff. Further on down the program here, it's going to print the word Gary, and then it's going to print the current balance of Gary, which would be, I guess, 200 less 100 or 100. And then it's going to print Mike and the current balance for Mike, which is a much larger number. Mike is at, looks like, I think 1019 with a checking deposit of 500, so it's 600 and change. And there's the end of my program. The important thing in this example is to understand that I can create multiple instances of Checkbook, depending on how many places I need to keep this information. Each instance of Checkbook has its own copy of data and its own set of methods. Okay, this one has encapsulation support, so it has get and sets. Again, this is a very simple example. It would be much more robust, and you'll see one of those in a few minutes, or well, in the next video. But this is a good start for what you're going to have for assignment 8. You'll have to keep instance variables for all those coffee data items. You're going to have at least one method that's going to print a label, and you're going to have a get and a set method for every one of the instance variables. Now, I would check, and I'll let you be creative on this. If it's a number, it probably needs to be greater than 0. If it's not a number, it may be required. In other words, it won't accept a blank. So then you'd say if inval not equal to blank, then accept it. And if it is blank, say, hey, this needs to be filled in. Or if not, exit the program. If you have any questions with this, there's book examples, there's other examples in Canvas. You can always send me an email, and I'll be happy to help you out also. Thank you very much. Good luck.